Now today we start new chapter, application of derivatives. So first we discuss slope of a line and then slope of a curve. So in class 10 and 11 we know how to find the slope of a line. If any 2 points on that line we know, then we find the slope by using y2 minus y1 upon x2 minus x1. If p of x1 y1 and q of x2 y2 are any 2 points on that line, then by using formula m is equals to y2 minus y1 upon x2 minus x1 we find the slope of that line. If we know the inclination, that means if we know the theta, that the angle made by the line with positive x-axis, then by using the formula m is equals to tan theta we find the slope of line. Here we start the chapter application of derivatives. That means derivative is nothing but the slope of that curve. If the function is y is equals to f of x, when we find derivative of this function, that is y1 is equals to f dash of x, this f dash of x is slope of tangent of the curve. That means here this f dash of x is slope of tangent of the curve. Suppose this curve is given, which is represented by y equals to f of x, and if a point on that curve is known, suppose that point is p of x1 y1, then we find the slope of this tangent for this curve at p of x1 y1. So we write this f dash of x at x1 y1 as the slope of tangent for this given curve. So here in this chapter we have to find the equation of the tangent. So for that we use this concept, slope of tangent at the as the derivative of that function. So this derivative f dash of x at x1 y1 is slope of tangent at x1 y1 for this curve y equals to f of x, or you can write y1 at x1 y1. This y1 is first order derivative. Now the normal is perpendicular to this tangent, and we know that when two lines are perpendicular to each other, then slope of one line is reciprocal of the other line slope, and which is negative. That means here we know the relation m1 into m2 is equals to minus 1. So we write m1 is equals to minus 1 upon m2. That means if we know the slope of tangent, from that we find the slope of normal to that tangent. So if slope of tangent is f dash of x, then slope of normal we write here slope of normal is equals to minus 1 upon f dash of x at x1 y1. So using this concept we find equation of tangent and equation of normal. For that we have to find the slope of that tangent first. From that we find equation of tangent and equation of normal. So if we have to find the equation of tangent at x1 y1, then we find y minus y1 is equal to m in bracket x minus x1. Here in place of m we have to write here f dash of x for equation of tangent, and for equation of normal we have to write here in place of f dash of x minus 1 upon f dash of x x1 at x1 y1. So we solve problem from exercise based on this equation of tangent and equation of normal. Now see first question from exercise 2.1. Find the points on the curve y is equals to x cube minus 2x square minus 1, where the tangents are parallel to 3x minus y plus 1 equals to 0. First we draw here a rough sketch for what we have to do in this question. So first we draw here a curve. We have to find point on the curve. So this curve we consider y equals to x cube minus 2x square minus x, and we have to find the tangent on this curve. So first we have to find the points on the curve. So we consider here point on this curve as p of x1 y1. That means we have to find the value of this x1 and y1 where the tangents are parallel to. So the tangents passing through this point, that means tangent to this curve at point p of x1 y1 is parallel to this given line. This given line has equation 3x minus y plus 1 equals to 0. That means here we find the slope of this tangent, for this curve, and which is parallel to this given line. From that condition we find the value of x1 y1, that means point on this curve. So first we write here in solution given curve y is equals to x cube minus 2x square minus x. So we denote this given curve as equation number 1. Now we have to find the slope of this tangent to this curve. So differentiate with respect to x. Therefore we get dy by dx is equals to 3x square minus 4x minus 1. Now we have to find the slope of the tangent at p of x1 y1. So we have to consider here point on that curve. So let p of x1 y1 be the point on the curve. So this point must satisfy this equation of curve. So right here, therefore slope of tangent at p is, therefore we write dy by dx at p, that is at x1 y1, is equals to 3x1 square minus 4x1 minus 1. But this tangent is parallel to this given line, and we know that if two lines are parallel, then their slopes are equal. So first we find the slope of this line 3x minus y plus 1 equals to 0. Then we write the slope of given tangent equals to that slope, because this given line and the required tangent are parallel to each other. So here we don't have to find the equation of tangent, but we have to find the point on that curve. So for that we equate the slope of given line and slope of tangent. So first we find slope of this line. So right here, slope of line 3x minus y plus 1 equals to 0 is 3. So you know how to find the slope of this line. We write this as 3x plus 1 equals to y. That means y is equals to 3x plus 1, and we compare this y is equals to 3x plus 1 with y is equals to mx plus c. So we get here m is equals to 3. Now this given line and tangents are parallel, so their slopes are equal. So we write here, therefore 3x1 square minus 4x1 minus 1 equals to 3. Therefore 3x1 square minus 4x1, we transfer this 3 to left hand side. So we get minus 3 minus 1 as minus 4 equals to 0. Now we have to find factor of this quadratic equation. So write 3 into minus 4 as minus 12, and we have to split up this. That means that product must be equals to minus 12 and addition must be equals to minus 4. So write minus 6, 2 as the factor. Here coefficient of degree 2, variable degree 2 is 3. So we divide this as by 3 and this also by 3. So we get here minus 2 plus 2 by 3. So the factors are, therefore x1 is equals to plus 2, x1 equals to minus 2 by 3. So you try yourself. So x1 equals to 2, x1 equals to minus 2 by 3. Now we have to find x1. We have to find from this value of y1. So this point x1 y1 lies on this curve. That means this point must satisfy this equation 1. So right here from equation 1 we write y1 is equals to x1 cube minus 2x1 square minus x1. Therefore when x1 is equals to 2, we get y1 is equals to 2 cube minus 2 into 2 square minus 2. So 2 cube is 8 minus 8 minus 2, which is equals to minus 2. Therefore first point we get, therefore P of 2 minus 2. 2 minus 2. Now we have to find another point. So for that we have to take x1 equals to minus 2 by 3. When x1 is equals to minus 2 by 3, then y1 is equals to, so we write therefore y1 equals to, here we substitute this x1 by minus 2 by 3, so we get here minus 2 by 3 its cube minus 2 into minus 2 by 3 its square, then minus 2 by 3 minus of minus 2 by 3. So right here cube of this minus 2 by 3 as 8 by 27 minus 8 by 27, here minus 2 into square, after squaring we get plus 4 by 9 minus minus plus 2 by 3. We require base same, so for that we multiply and divide by 3 to second term and multiply and divide by 9 to third term. So write minus 8 by 27 minus 8 by 9 into 3 by 3 plus 2 by 3 into 9 by 9. So we get here after base same 9 into 3 27, 3 into 9 27. So we write here 27 minus 8. 3 are 24, so minus 24 to 9 by 18, so plus 19, which is equals to. So here we write this value as minus 14 by 27. So when x1 equals to minus 2 by 3, we get y1 equals to minus 14 by 27. Therefore coordinate of point P are minus 2 by 3 and 14 by 27. So in this way we get coordinate of point on the given curve as 2 minus 2 and minus 2 by 3 minus 14 by 27.